All right. Hi, everyone. How are you? How are y'all doing? You guys enjoying Unite? This is actually my first time at Unite. I'm super excited to be here. I've been having a really good time here. So I'm really excited to be here and be able to give this talk. So this talk is technology and user experience. And it's about creating immersive interfaces and interactions specifically for VR and mobile. I did not realize how long the title of this was until I tried to fit it on a slide. So welcome. First, who am I? My name is MJ, and on Twitter, I'm at MoreKitties, if you feel like following me. I'm a game developer. I've been making games for a while. I primarily use Unity for the games that I make. I founded my own studio earlier this year, and I'm also a teacher. I teach interface design and prototyping. And what is this? This is listed as a beginner talk on interface design for unique platforms. I listed it as a beginner talk because you don't really need a lot of technical experience to follow along with it, but I hope that it'll be useful to you even if you're not a beginner. And also it's listed as a workshop, so I will be showing you some stuff in Unity, but you don't need to follow along in Unity because I have a Unity package that you can download and you can play around with the demo afterwards. I can share the link with you guys. So usually I start off with an intro of things that I've made and things that I've done. But I'm actually going to show you some things that I've done throughout my talk as examples. So just very briefly, I got my start at Carnegie Mellon University. I had a lot of great opportunities to use unusual technology there. And that was really what got me interested in using unusual technology in unusual ways. After that, I went and worked in VR for a while. I made some VR demos for Virtuix, and I'll talk about some of those later. And then I worked in mobile games for a while. And then I did a brief stint in AAA, worked for about a year, most recently on the Call of Duty Modern Warfare Remastered, so that was exciting. And then earlier this year, I founded my studio, Astire Games. So I want to start by talking about hardware. Hardware is the precursor to design. When you are starting to design for a game that you want to make, you want to start by thinking about your hardware and your input. You want to be really aware of what it has to offer. So here's a list of some common types of hardware that you've probably played with or possibly made games for. So mouse and keyboard, obviously, gamepad, controller, motion-tracked controller, head tracking, and touch screen. And this list is a little bit more obscure, so you need to think a little bit differently when you're designing for these kind of platforms. So we have the Kinect, the Wii Balance Board, heart rate monitor, or other biometric feedback, 3D stylus, specifically for the ZSpace, which I'll talk about, 360 Treadmill, and Leap Motion. So this up here is the full list of all of the hardware that I've developed games for. Whenever I'm developing for a new piece of hardware, I like to start with the question, what can this hardware do that no other hardware can do? And then follow it up with, what can I make for this input that I couldn't make for any other kind of input? This helps me get started with my design process to think about what the hardware really has to offer and how I can use that to my advantage. So I'm going to try to answer those questions about a couple of different kinds of hardware that I showed on the screen. So the first is the ZSpace. How many of you guys have ever played a game on the ZSpace? 2 people. How many of you have ever made a game for the ZSpace? 1 person. Hey. All right. So I made a game for the ZSpace. So if you've never seen one or used one, the ZSpace is a semi-holographic tablet. What it does is it has 2 cameras on it, and then it has a pair of glasses that have trackers, and then those trackers allow you to view the screen projected towards you as a hologram. And then it also comes with a 3D stylus that lets you actually move the stylus. It's also tracked, so you can move the stylus around in 3D. And you can move your head around to actually look around things and behind things. And it's really hard to imagine this hardware without actually trying it. So you'll just have to take my word for it that it looks really real. When you're wearing these glasses and looking at the hologram, it looks like something you could reach out and touch. So I have a little thing to show. I made a game with had a team of programmers and artists, And we started with the question, what does this hardware have to offer? And the thing that's really most unique about this hardware is the 3D-ness of it. And we really wanted everything that we did to revolve around that 3D aspect. We wanted the players' interactions to make them aware that they were interacting in 3D. So we made a game where you're trying to protect these little bunnies, and you're moving them around on these floating islands. And we chose floating islands for our environment because we wanted the environment to project nicely out of the screen, as opposed to looking down into a box. The islands come towards you. Up in the corner there, you can kind of see that's a renderer that shows you what it looks like when the player is using it. So you can see how the floating islands come out of the screen towards you. And then your interactions are to draw bubbles around the bunnies to make them float up. And so you're moving them in 3D space. You move them up and around and then back down. And you're moving them into these little safe zones. And one of the things you might notice on here is we have these little signs that tell you how many bunnies you've lost. That's how many bunnies have been eaten. And we put feedback and we put information in the world because putting an overlay on the screen completely destroys your immersion and your understanding of the 3D depth. So everything that we did was focused on keeping the immersion in that 3D setting. And then we also added a flying enemy a little bit later on because we wanted the player to have danger in the full 3D space. So there's danger when you're on the island, and there's also danger when you have the bunnies in the air. And there's also a chance for the bunnies to blow away, which was kind of fun. We added a dynamic wind system that made that interaction a lot more fun. The reason we chose drawing bubbles as our primary interaction was because the 3D stylus was a lot of fun to draw with. There's different things you could do. You could pick things up. You could poke at things or move things or push things. But we really enjoyed drawing 3D shapes. We started out with drawing cubes, but then we just discovered that drawing bubbles was actually really exciting for a lot of our players. So that was the primary interaction, and we felt like it really took advantage of what that hardware had to offer. All right, so let me switch back to this. So next up is the 360 treadmill. This one is the Omni, the Virtuix Omni. So I worked for Virtuix a while back, and the thing that's really unique about this hardware was pretty obvious. You're walking. The input is which direction you're walking and how fast you're walking. And this is usually paired with VR. It doesn't have to be, but it's usually done with a VR headset. So you're immersed in this world in the VR headset, and you can turn in any direction and walk on this treadmill, and that translates to movement in the game. Now, this translates pretty comparatively to the input you would get from a joystick on a controller if you were moving around the first-person game. So the Omni translates really well to a lot of first-person experiences. But the biggest difference is that the Omni, when you're walking on the Omni, you actually are physically moving. So if you want to turn around and face the other way, you have to turn your whole body. And it's a much slower movement than if you're just using a thumbstick to turn around. And so what happens is if you're designing an experience and you're testing it on a controller, you get the false impression that the user can turn around very quickly when in fact they can't. And you might be tempted to put interactions where maybe you hear something or you see something out of the corner of your eye and you want the player to turn and shoot or something. So working with the Omni gave me a really strong appreciation for the importance of testing on the hardware that you're going to release on. While I was working there, it was at the point, it was so several years ago, so the hardware was not very stable. So I spent a lot of time testing on the controller, and then at the end of a development cycle, when they had a stable version of the hardware, I would test it on the hardware, and there was just so much difference in your understanding of the movement. And so that also contributed to my desire to make things that are specific to the hardware. So the demo, or one of the first things that I made for the Omni, when VR was first starting out, a lot of people thought about virtual tourism, which is pretty cool. And I thought that would work really well with the Omni because you're moving, you're walking around, and that's what you do when you go on a tour. When you're touring a new city, is you walk around in that environment. So I made this virtual tour of Amsterdam. So you walk around, and one of the things that I added to it, which I hadn't seen done previously, was the ability to take pictures, because that's the other thing you do when you're on a virtual tour. So you take pictures, and then when you're done, those pictures are saved to your computer. So it's like you actually went and walked through that space and took your pictures and then came back home, and you can share those pictures with your friends. And it also tracks how many steps you take and how far you walk. So you could even use it for exercise. So instead of going out for a jog, you could go and walk around Amsterdam instead. All right, so the Wii Balance Board. How many of you guys have played a game on the Wii Balance Board? Yeah, how many of you guys have made a game for the Wii Balance Board? A couple of you. All right, cool. So the Wii Balance Board, if you haven't seen one, it's a pressure sensor that can tell which direction you're leaning. It's very accurate. It's very good at telling what you're doing. So if you pick up a foot, it can tell which foot you picked up. If you step forward, it knows you step forward, or if you step backward, it can tell which direction you moved that foot based on the foot that's still standing, where you're putting that pressure. I've actually tried to trick it before, and it's very difficult to trick. It's really good at detecting those movements. So if you're making a game for the Wii Balance Board, you know that your input is the player leaning. So what can you think of in the real world that you would control by leaning? My first thought was a hoverboard. So if I was flying around on a hoverboard, I would steer it by leaning. So one of my projects was a hoverboard-based game where you're flying through a subway and on these hoverboards. It's actually a two-player game, so we have two Wii Balance boards. You can see up at the top, that's two players playing. And so we actually paired this with the Kinect, because we also wanted to use upper body motion. So the Kinect is really good at detecting whether you're, the angles between joints, so whether your arms are straight or bent. So we have this mechanic of punching to fire these plasma projectiles. And then one other thing that we added to this, so this was intended to be an exercise game, and so we strapped on heart rate monitors to our players because we needed the data. It was a research project. But at some point we decided that we actually wanted to use the heart rate to influence the gameplay. And so what we did with that was we took a baseline of the heart rate reading, and then as the player's heart rate increases, they gain strength. They build up this, you can see the power meter on the side. That's how much their heart rate has increased. So this is positive feedback for the player for an exercise game. It tells them how hard they're working, how hard they're trying. And it also actually leveled out the playing field between players who were in really good shape or players who were in not so good shape. If you're in really good shape, it actually takes more work to elevate your heart rate. And since we were taking a base level heart rate, players who were in really good shape actually had to try even harder than they normally would. So including the heart rate was a really interesting addition to this one. And as you can imagine, with having all of this hardware, it was really difficult to map any of this to mouse and keyboard, even for testing purposes. In all of my games, I try to make hotkeys so that I can test things on the computer, so I don't have to be constantly making builds. And this one was one where we had so much input, and the input was so unique that we couldn't even have, we ended up mapping like 12 or 14 keys, and we still didn't come close to all of the interactions we needed to cover. So we were making builds for this constantly and constantly testing on our hardware, which was really good for us because it gave us that feedback that we needed about how the hardware would work in different circumstances. All right, so next up is the Leap Motion. How many of you guys have used the Leap Motion? Cool. How many of you guys have made a game for the Leap Motion? Yeah, so they do periodically, they do game jams, and sometimes they'll actually give away free ones when they do their game jams, which is super cool, and I would encourage all of you, if you're interested in trying different kinds of hardware, to sign up for one of their game jams. I got my Leap Motion through one of their game jams. The Leap Motion, probably all of you know how the Leap Motion works. It's sort of like a teeny tiny Kinect. It's a Kinect for your hands, so it tracks the motions of your fingers and it maps it to a skeleton. And so it makes really immersive hand motions, so you have the full dexterity of your hands to interact in the world. It's really great for gestures, and it's great for things that require you to use your hands as if you were using them in the physical world. And so when I got my Leap Motion and I was trying to think of what kinds of things do you need to use your hands for, that it's not the same experience if you're not using your hands. And the first thing I thought of was gardening. There are a lot of games that try to do gardening simulators or farming simulators, but it's really difficult to get the same experience using a mouse and keyboard as if you're actually digging in the dirt. So I wanted to have that experience of using your hands as if you were actually digging in the dirt. And so one thing though, when you're trying to map a digital experience to a real world experience, you don't need to match it perfectly the way it would be in the real world, as long as you're getting the core essence of that experience. You can do some really weird things, and that can be sort of empowering and exciting for players. So what I actually did was, I made a garden simulator where you are pulling the plants out of the ground to make them grow. So you are growing the plant manually. And if you pull it too hard or too far, it will pop out of the ground. So I made this in 24 hours. It was for a game jam. That's why the graphics are so weird looking. That's what you get in 24 hours. But so you pick up the seeds, you plant them in the ground, and then you pull them up to grow them, and then you sprinkle water on them with your hands. So you dip your hands in a water bucket and sprinkle to make them bloom. Don't do that. Okay. All right, so I'm going to get to virtual reality very soon. I wanted to preface with a lot of different kinds of hardware to give you a sense of the importance and the value of different kinds of hardware and what different kinds of hardware have to offer. And just before I get to virtual reality, I want to talk about augmented reality. I haven't actually made anything for augmented reality yet, but this stuff is really cool. Augmented reality basically refers to anything where you're overlaying something digital on top of the physical world in some way. So this can happen with the HoloLens, the AR glasses, or like the things that you use with your phone or tablet where it has an overlay on the screen, but also you can see through the outward-facing camera, so like the Google Tango. And then also things are done with projectors. So this is a projector that the color it's projecting is based on the distance to the surface that it hits. So this is creating essentially a depth map. This here is a sandbox, and you can move the sand around. You can pile it up to build mountains, or you can dig out lakes and valleys. And in real time, it updates that color that you're seeing to create a visual depth map. I had a chance to play with one of these a couple weeks ago, and it's really fun to manipulate things with your hand and then see a digital update happen because of that. Now, AR, a lot of times people use it interchangeably to refer to two different things: augmented reality and alternate reality. Alternate reality is actually more like a parallel universe that exists in the same global coordinates as our world, but is inhabited with Pokemon. All right, so I'm going to talk about virtual reality now, but I want to quickly draw a distinction between head tracking versus a head-mounted display versus virtual reality. So a head-mounted display is actually just a display. It's like a monitor that you are wearing on your face. It's not actually tracking your head, so it's just displaying a screen. And it can be really cool for like watching movies. It makes you totally immersed in this space, but you can't look around. You're actually just fixed at your viewing angle. And so it creates a neat experience for something that's stationary, that you're not looking around the world. Head tracking can be done with or without a VR headset. The ZSpace, which I mentioned earlier, uses head tracking, but those glasses you can see through. You can see through into the real world. There's nothing digital on those glasses. It's just the trackers. It's just a piece of plastic with trackers on it that are being read by the cameras. So head tracking allows you to create a 3D effect. And you can use that to create a 3D effect like a hologram, but you can also use that to create a 3D effect in VR. So a VR headset combines head tracking with a head-mounted display. So you're displaying the screen like right in front of your eyes, but you're also tracking the head motion, tracking the rotation, tracking the movement to create a fully immersive experience. So you're actually embedded in that world and you feel like you're a part of the world. All right, so that was my intro to unusual hardware and platforms. So we're going to talk about designing specifically for VR and for mobile. VR offers a lot of really unique opportunities that are different from anything that we've ever really designed for before. Being able to actually look around and move around your environment using your head and your body, this is completely different than the way we've been previously designing games and experiences. And I would argue that we should really be thinking about VR in a similar way that we think about designing for mobile. So mobile's been around quite a bit longer, but we learned some really interesting things from designing things for mobile. In the early days, when people started designing things for touch screens, the instinct was previously you would click on something with a mouse, so now you tap on it with your finger. And we just had this direct translation. We had things that were already built for a mouse, and now you tap it with your finger. But what we learned from our experiments with the touchscreen is that it's very intuitive. So intuitive, even toddlers can use it long before they could ever use a mouse. And part of that is the dexterity. You need to be able to hold the mouse in your hand. But a big part of it is actually because of the disconnect. When you're using a mouse, you're holding this physical object and you're moving it around on a flat surface, and then you see on the screen, you see the mouse cursor move, and you need to be able to make that connection. Me moving this is causing this effect. You don't need to make that connection with a touch screen because the thing you're touching is the thing giving you the feedback. So if you have something on the screen and you touch it and it explodes, you know that you caused that. That was a direct feedback to your action. And that's why toddlers can use touchscreens and understand what they're doing. They don't even need to be taught. They just understand when they touch it, something happens. And touchscreens also gave us the opportunity for gestures. I vaguely remember when gestures started happening on touchscreens. I remember back when I had my flip phone and then going to my first smartphone, and it was kind of a weird thing. It took a while to get those interactions to feel good. But gestures opened up a lot of really great opportunities for the touchscreen that we didn't have with the mouse and keyboard. And one of them, I think, that sticks out most to me is pinching and stretching to zoom in and out of something. This gesture, I think, is kind of brilliant. It's so intuitive, and it makes sense, and it feels good. And at the time when it was developed, it probably took a while to come up with something like that because there is no comparable pinch and stretch with the mouse. We were used to using a mouse, and there's nothing you can do with the mouse that feels similar to pinching and stretching. So when you're designing for virtual reality, it actually, similarly to the mobile devices, being intuitive for touching the screen and moving things around, the VR headsets give us more intuitive navigation. So where previously we were using the mouse to look around on a screen and WASD to move around in the space, now you're actually using your head and your body to look around and move around. And it's much more intuitive. People understand when you're looking around and you see that effect, it makes sense. And we want to use that intuitive nature for things. VR also gives us the opportunity to use gestures. So similarly to the touchscreen for mobile, where we started developing gestures that are intuitive and that feel good and that give us a wide range of opportunities besides just clicking on things. VR also has the ability to do gestures because you're usually moving controllers around, or at the very least you're moving your head around. And so you're physically moving something, and we can read those gestures and we can map those gestures to interactions in the game. So a few weeks ago, I played a VR hangman game. And they were doing some interesting things that were pretty cool, where you were actually acting out the clue that you're trying to give to another person, and then another person would then be the one playing hangman and guessing based on your movement, based on your clue, what was the correct answer. And that was really cool and really immersive, and it felt really good. But then when you actually get to the point of guessing, they pull up this little digital keyboard and you point at it with your controller and you click with the trigger, and that's how you guess. And to me, this was a little bit frustrating because there's so many opportunities with VR. There's so much we can do with VR. Why are we taking this step back and using a keyboard? We've already got keyboard stuff. There's just so many other things that we can do in VR. Why bring a keyboard and a mouse? Because it actually was both. You're pointing and clicking like you would with a mouse, and it also slows you down. You can't type, obviously, nearly as quickly by pointing and clicking at the letters as you would with a keyboard. So I think seeing a digital keyboard in VR is one of the things that most pulls me out of the experience. It doesn't feel good, it's not satisfying, and it tends to frustrate players and slow them down. So on the totally other end of the spectrum is, oops, I didn't mean to do that. So on the totally other end of the spectrum, there's this game called Fantastic Contraption. Many of you guys have seen it. So this used to be actually a Flash game, and they recently ported it to VR. And so this game, you're moving things around, you're building things, and they do really cool things with gestures in this. The gestures are based on your physical body, your physical space. So you reach, like if you wanted a stick to build with, you reach behind you and you pull out a stick, and now you have that to build with. And it's really easy to remember where things are based on your body. We're really good at that. Our brains are really good at remembering those things. So once you've done that once you've done that motion of pulling something out from behind you, you know this is where things are. I can pull things out to use them from here, or like from the side of you. So like mapping things to specific parts of your body is an easy way to remember where things are. And they also did a really cool thing with the interface. They have this little living interface, the kitty. Oh, there it is, perfect timing. So they have this little kitty, which is your menu that follows you around. And that's a really cool way to have the menu that is in the physical space around you and not distracting you, but have the ability to have it whenever you need it. OK. Oh, that was body gestures. I actually had one more video. Shouldn't switch back. So in addition to body gestures, you can also use head gestures. So this is one of the games that I'm working on. And in this game, it's entirely gaze-based. This is for the Gear VR. I'm not using any controller input. You stare at things to collect them. So that's your primary interaction. And then you have this UI, which is below your screen. You can see a little bit of it there. And when you look down, it comes to you. So no matter where you are, no matter which way you're looking, you look down and it brings your menu to you. So looking down then is your gesture that you're using to you remember that action brings your menu. Okay. So enough examples for a little bit. I want to talk a little bit about terminology. So when we're talking about UI and UX, there's a tendency to use these terms ambiguously, and it can actually make it really difficult for us to communicate effectively about the things that we're making. So the user interface is everything that separates the player from their experience. This includes the physical hardware, the buttons that they're pressing, everything that they're using with their hands or their head. All of that is part of the interface, but then also the digital interface, which includes the heads-up display and the interactions that the feedback that happens on the screen, buttons that they press, and menus that pop up. So the interface is everything separating the player from the experience. So the user experience is what they're actually doing, what they're actually experiencing. How do they feel doing these things? What is their goal, and how do they accomplish their goal? So the user interface allows them to have the user experience. Think of it like a tool, the tool that lets them play the game. And when we're talking about user interface, we don't even need to talk about video games. When I teach interface design, I like to give an example about driving a car. If you were driving and I was sitting in the passenger seat and I asked you, describe to me what you're doing right now, you might say, I pulled up to a stop sign, and then I stopped, and then I turned left. You probably would not say, I pressed my foot down on the brakes until the car came to a stop, and then I moved my foot to the gas pedal and I pressed down on that as I turned to the steering wheel to the left. When you're driving a car, you're immersed in the experience, and when you describe the act of driving a car, you're actually describing from the perspective of the car, not the perspective of your interaction with the interface. And this is really what we want when we're designing an interface. We want players to describe their experience, not describe the interface. The interface is best when the user doesn't realize that they're using it. The only time players really notice the interface is when it's bad. And you can see that in the physical world as well. Have you guys ever seen the doors that have a handle on both sides, and one side you push it and the other side you pull it? And that's just extremely frustrating. It's not giving you the right information. And you really only think about those doors when they're done wrong. If you walk through one that was done correctly, you'll never even notice it. But as soon as you hit one that has a handle and you're actually supposed to push it and not pull it, handle tells us that we pull, and that throws you out of that experience. All right, so I'm going to give a few obvious tips, and you might be thinking, if they're obvious, why am I going to tell you? So just because they're obvious does not mean that we do them. And a lot of times they're just things that we have to remember to do them. We have to consciously choose to do them. Also, just because they're obvious doesn't mean they're not important. In fact, the fact that they're obvious makes them more important. So first is don't block the player's view. And this is really obvious, if you have something on your heads-up display or something on your interface, and the player's trying to play the game and it's in their way, they're going to have trouble playing the game. This is going to throw them out of the experience. The second is be intuitive. So when a player is getting started playing a game, as much as possible, you want them to understand the interface without being told. You don't want to have an entire tutorial just to teach them how the interface works. Things in your interface, as much as possible, should just make sense immediately. If you have a health bar and players don't understand that that's showing them their health, maybe you need to find a way to make that more obvious and more intuitive, as opposed to having a text pop up that says, hey, this is your health. You don't want to have to tell the players what the interface is. Don't slow the player down. So if there's something that they need to go through a menu to do, have that happen as quickly as possible. Don't put barriers in the interface. Don't make the player jump through hoops to get something done. The interface should allow the players to do, as soon as they know the thing they want to do, the interface should let them do that as immediately as possible. Don't confuse the player. So a lot of times when you're designing a game, you might have the kind of game that you want the player to have to think cleverly and creatively to solve problems. You want them to they're solving puzzles, and so you don't want them to understand things right away, but that does not apply to the interface. The game should require the player to be clever, but the interface should not require the player to be clever. Give useful feedback and information, and give it very quickly. The delay that you have between what the player did and when the feedback happens, that delay determines how likely the player is to register that they did the right thing. And also, if there's too much of a delay, there's a high probability the player is going to think that your game is broken. And user testing, which has a lot of exclamation points, because it's really important when you're designing an interface to test it with other people besides yourself. You are the worst person who could possibly test your interface because you built it and you know what the buttons do. So test constantly and make sure, test silently. So watch people use it and see what they don't understand. That's the most useful information you can get, is watching silently as someone completely misuses your interface. So user testing, very important. So a couple of obvious tips that are specific to mobile. Don't make the player reach across the screen. This in particular for tablet games, players will hold in one hand and they'll be interacting with the other hand. If you have all of your options on the far left side, they're going to spend their time touching the left side of the screen, and their hand is covering everything interesting that they could be looking at. So put interactions in a way that they don't need to reach across the screen. And for that reason, you should have a left-handed mode, because some players will play with their left hand and some players will play with their right hand. Reduced repetition. So this is something that happens a lot in mobile games, is having to click through a lot of things. And if you're doing the same thing over and over and you have to make the same click-through cycle, it's going to get frustrating very quickly. So if you have something the player needs to do multiple times, give them a way to do that, to stack that, and to do that all at once. Like for example, if you had an inventory and players could sell things from their inventory, maybe let them select a bunch of things at once and hit sell, instead of selecting something, hit sell, and then hit the next page, and then go back and then hit the button again. So give them ways to do things quickly. Buttons should be bigger than your finger. There's a tendency when you're porting something to mobile to just reuse the same interface and the same buttons, but the mouse is very precise and very good at hitting very small buttons. Our fingers are not. Our fingers are large and they get in the way and they block our view, and it's hard to hit small buttons. And that is one of the things that will make players immediately stop using your game if they can't even hit the start button. And then touch and drag. So there's a tendency to, if you're moving something on a screen, to touch it, to select it, and then touch the spot you want to move it to. It's a lot more intuitive and a lot more satisfying to actually touch and drag. The whole clicking to select and then clicking the place you want it to go came from using the mouse, and It works well with the mouse and it makes sense with the mouse, but on a touch screen, it makes a lot more sense to touch and drag, and it feels better to the user. Oops, these didn't come up one at a time. Sorry about that. So obvious tips for VR. You get all these at once. So do not stick the UI on the screen. Use spatial UI. The camera that you're rendering to your face, if you have UI stuck to it, so you're looking around and the UI is always fixed on the screen, for one thing, that's actually going to mess up your depth perception and mess up your ability to understand the space. But for another thing, if you wear glasses, if you ever had something stuck to your glasses, and so you look around and it's always stuck there with you, and it's super frustrating. So don't stick things to the screen. Also, if you stick something to the screen, you probably are putting it around the edge. And so that's actually forcing the player to look with their eyes instead of looking with their head, and that can cause eye strain. So don't stick things to the screen. Don't put things too close or too far away. The recommendations that I've seen are 2 to 3 meters is a good distance. So if it's too close to you, it can like make you, give you like a headache or make you feel uncomfortable or make you feel like it's violating your space. If it's too far away, the player might have trouble seeing it and understanding what it is. Use face and body gestures to replace buttons. So I was talking before about some examples about how you can use your face and your body so that you don't need to have things pop up that you click on menu buttons. As much as possible, use gestures. Make text readable, and this is really obvious, but it's amazing how many times we forget how important it is to make the text crisp and also use good fonts. There's nothing more frustrating than being in VR and seeing some instructions that you can't read, and you have to squint to look at them, and it causes you to have a headache, and then you get annoyed. And then the last one is draw targeting reticles in the world. So as opposed to drawing a targeting reticle on the screen, if you need to be able to focus on a specific thing, raycast from the player into the world, and then draw a physical targeting reticle in the world. This gives players a better sense of the space and lets them know what they're actually focusing on, and it actually helps reduce motion sickness and makes the player feel more comfortable. So by far the biggest tip that I can give, no matter what you're designing for, whether you're designing for VR or mobile or any other unique hardware, is to step away from the mouse and keyboard. When you start designing, don't design while you're sitting at your mouse and keyboard. Get away from your mouse and keyboard, maybe put on the thing that you're going to use. So you're designing for VR. Don't design while you're sitting at your keyboard. Go put on a VR headset and think, what does it feel like? What would I be doing? What interaction would I do to make something happen in the game? Then go back to your mouse and keyboard and type up the code. Unity is helping make this a lot easier for VR with their in-editor VR level builder. But it still doesn't help with the fact that we're probably going to be taking off the VR headset when we're writing our code. I can't imagine a lot of people are going to write their code while wearing the VR headset. So you're probably still going to end up testing at some point without having the VR headset on. So always just keep that in mind. If you are testing on the mouse and keyboard, just remember, I'm not actually going to be using the mouse and keyboard when I'm playing for real. So just have that thought in the back of your mind. And I think this will help get us away from that instinct of creating mouse and keyboard interactions for a hardware that doesn't use mouse and keyboard. All right, so I'm going to show you my demo scene. So if you want the file, this is the short link. You can take a picture of that. I'll put it up on the screen again when I take questions. So I want to give credit to I got a free Unity asset from the asset store. I can't say that name. Quasi. Anyway, I want to give credit, so I used that from the asset store, and it is in the package, and I know you're not supposed to redistribute them, but I'm only giving it to you guys. And it's free. It's a totally free asset pack. You guys could all go download it right now, and it's a really cute one, so I recommend it. All right, so the first thing I want to show you is this is the basic setup that I made for the UI that I did for my VR game. So first is put instructions in the world. And then using head gestures to bring your menu to you. So you look down, there's your menu, and once the menu is up, it's static and in place, so you can select it, and then you look up and you can move back around, and then no matter where you are, it comes to you. So I have the code for that here, which you guys can just have and use if you want to make a game that does that. So it's called UIMover.cs. And so basically what it's doing is it's detecting when you look past a certain degree, or past a certain angle with your camera, and then it's raising or lowering. So first, I did it kind of backwards. So it's actually my first if statement is lowering the camera, and then my else statement is raising, or lowering the UI and then raising the UI. And then I'm turning the text off when you look up. So when you're looking around the world, I'm turning the text color off because it's a 3D text. And you could fix this with a different material or different shader, but I'm just using the default shader, which draws through everything. So I'm actually just turning it off when the menu goes away. So one thing, while I have the text up here, so when you're creating a UI in Unity, probably you guys have all used Unity's UI canvas. So if you were to create a text, you would go to UI text, and you would create something that's going to be stuck to the screen. For putting text in the world, it's under 3D text, or 3D object and then 3D text. And so this creates a physical object in the world. And what was I gonna say? Oh yeah, and make sure when you do this that you adjust the font size. So by default, it comes in with I think it's like font size, it shows up as 0. I don't know what the actual font size is, but it shows up as 0. And it's really fuzzy. Let me see if oops. So if you create a new one, actually here, I'll just create a new one and show you. All right, so by default, when you make a new one, look how fuzzy that is. That looks terrible. So don't use it at its default settings. Oops. The default settings where it says font size 0. So you want to make that really big, like 32, and then scale the size down. You can either scale it with the scale tool, or you can change the character size. So you make the text smaller, but the font size bigger. And the bigger the font size, the crisper it will be. So just keep messing with those numbers until it looks as nice as you want. So I found numbers that I liked for this one, and I think it looks all right when I play it. And then always test it in VR and make sure it still looks all right, because if you are playing it on your screen and it looks okay, it doesn't necessarily look okay in VR. So then, let's see, where was I? Oh yeah, so then I also have this look at UI.cs, which is what's detecting which menu option you're looking at. So it highlights the one you're looking at. I'm switching between materials. I'm doing a raycast, and then based on which one I hit, I'm switching the material of that one. So you can see, hopefully the projector looks okay. Come here. So which one I'm looking at gets highlighted. And then what I do in mine is, since there's no controller, I wait 2 seconds, and then I say, okay, you've selected that thing. What you might, if you had controllers, you might push a button on the controller in order to select that, but still using your face to pick which one you're looking at. All right, so that's the UI interface that I have for you. And you have in the package, if you download it, I'm sure you guys all know how to do this, but if you download my package from that link that I put up there, you just start a new project and then go to Assets, Import Package, Custom, and then you find that package and import it. Excuse me. And then that package has all of my scenes, all of my scripts, everything that you could possibly need. All right, so a mobile example. So the mobile example, I am using Unity's Canvas. And the one thing that I would say, if you haven't used the Canvas specifically for mobile, the default when you create a new canvas is under Canvas Scaler, it defaults to constant pixel size, which works okay on PC. I'm not really sure why that's the default. I always switch it to scale with screen size. But constant pixel size works okay if you're developing it on a PC and releasing it on a PC. But constant pixel size means everything you're putting on the screen is always going to be at that size. And it's not going to scale if you go to a higher resolution. And if you've developed anything for mobile at all, you know that every mobile device has completely different aspect ratios and completely different resolutions. The aspect ratio is frustrating enough because the dimensions are always weird when you try it on a different device. But the resolution is actually why you need to set this to scale with screen size, because some of the older phones and devices have a super low resolution. So then everything that you create is going to be huge on your screen. And then some of the newer devices, like my phone is 1600 by 900, which is even bigger than the resolution of my computer. So everything is super tiny and really hard to see. So I always set scale with screen size when I'm designing a UI for mobile. And then, so everything in the canvas, it renders in the order that you see it on here. So if you need to change which order something is, you would just drag it to move it to a different, oops. So like if I move my BG all the way to the front, now my background is rendering all the way at the front. So this is the order that things render. And so I have a couple of buttons on here, and it's just good to note that these are all very large and hopefully very easy to read. And you may notice that they don't have a hover over color when I hover out with my mouse. You don't need a hover over color if you're designing for mobile, because there is no hover in mobile. Like once you put your finger on it, you have tapped it. And then this is one of the interactions that I like doing in mobile is touch and drag. Touch and drag feels kind of weird with the mouse. So what I'm doing is I'm clicking and I'm dragging. It feels kind of weird with the mouse, but it feels really good with a touchscreen. And there I have a little bit of parallax going on that makes the environment feel a little more immersive. So this gesture, this touch and drag, is one of my favorites to use for mobile. And I have a script here for you that does that if you want to use touch and drag in your game. So it's called movingenvironment.cs. So I have the Android version up here, which uses the touch. So input.touch is how you determine if the user is touching the screen. The index 0 is the first touch. So you touch with one finger and then you touch with another finger. So it's only going to track one of them. But this allows you to touch and drag. And then I have the mouse version down here. Now, technically, if you put the mouse version in, it will actually work on mobile. Like if you just have click, the mobile detects touch as click. But it's not a good practice. I would suggest always use the touch version when you're on a mobile device, and then use the mouse version when you're on a PC. So I added this in here just so that it will work for my demo, because the touch won't work when I'm demoing it. And then if you haven't worked with buttons in the Unity UI before, they're super useful now in the Canvas version. If you worked with Unity a long time ago, they had the NGUI system, but now the Canvas system is a lot more intuitive and a lot more fun to use. So they have pre-built buttons that are already set to detect when you click on them, and then you just make an on-click function. And it's super easy to make an on-click function. You just make a script that has a public function, and you can do anything that you can do in script, you can just map it to a button. So I click on this button, and it'll run any function that I want to. So I don't want to talk too much about what's going on in this code unless, probably the only people who use this are if they're coders in here. And it's pretty straightforward and it's pretty easy to use. So if you wanted to use any of these things in your projects, if you're making a mobile game or you're making a VR game, you're free to just use them as they are. They're yours now. I give them to you. So here is that last slide with the link again, and also my contact information. So again, my name is MJ. I'm on Twitter as @morekitties. I have a couple minutes left to take questions. I do also want to mention I have my link to my blog up there because while I was coming up with my idea for this talk, I actually did a brain dump of all of the things I wanted to talk about in my blog. So you can basically find a text-based transcript of this entire talk on my blog if you feel like reading it. And it has links to everything that I showed, all the demos that I showed. So there's that for you, and there's the demo for you. So now I can take questions, if there are any. Yes?
You mentioned the reticle in the 3D VR environment.
Mm-hmm.
Would you suggest lining that up exactly where they're looking, or a little bit below?
I've heard different opinions on that. I think a tiny bit below can help make it easier to focus on, because right in the middle of the screen, the center of the screen actually feels kind of high up when you're looking in VR. But really that just requires testing, so try it at different heights. User testing for VR is just super important. So test until you find a good height. Yes? With what? Smoothing. Oh, yes. So it's helpful to have a slight delay. So if you move very quickly, have the reticle is actually updating its position to catch up to where you're looking. Yes, thank you for that question. I totally forgot to mention that. It is really helpful to improve the comfort level of the player if it's not constantly snapping to where they're looking. Because again, you get that feeling of something stuck to your face. Yes, thank you for that. Any other questions? Got about 2 minutes left. Yes?
I got really excited when you said you had keyboards in VR.
Mm-hmm.
Because they're portable, but then you put up fantastic contraptions, which actually doesn't use a keyboard interface.
Right.
Have you seen anything or any idea how you would represent a choice between 30-ish items?
Okay, so that's a very good question, and I unfortunately don't have a very good answer for it. I've talked to other people about how can we stop using the keyboard in VR, and I've heard people suggest like using voice commands. So if you needed to type something in, if you needed to rename something, using a voice command to rename it, which I think would be super useful. But the voice command doesn't take away from what you're suggesting, which is you need a lot of different options, and a keyboard gives you a lot of different options. For me, I feel like when I think about it, what I think is that there are so many things we can do in VR. We have so many options of things to choose from that we don't need to lay it out in front of you and let you pick things, because you can just do things. You can design your experience so it's more active and less about consciously choosing between options. I see the value in having a keyboard for having a lot of different things to choose from, but we already have PC games for that. So I guess my argument and my instinct is let's look at what VR can do and give options that way, which is why I brought up gestures, because with gestures you have almost unlimited number of things that you can do and map those to actions that the player is physically doing. And that's easier to remember and also more satisfying to do. Yes?
Can you talk a little bit about user feedback? They want that feedback after they perform an action, and the role that audio plays in that, and specifically in VR, how that's different because of the interface of the headphones.
Yeah, so feedback? So, okay, sorry, it was a little hard to hear. All right, so giving feedback in VR. Yeah, so all of the VR talks that I've seen so far at Unite have talked about the importance of feedback and the importance of using sound as part of your feedback. And yes, feedback in VR is vital, and having sound is really useful in VR because we're already embedded in that spatial environment, and having headphones lets you use full 360 sound to put the sound in the environment around you. And that helps to further ground you in that experience and make you feel like that environment is real. So as much as you can make the feedback part of the world, that helps keep the player immersed. If your feedback is like a text pop-up that tells you a number like, oh, you gained 10 points, that doesn't keep them grounded and immersed in that experience. But if you have like something explodes and you look at it and you see like the explosion happening, so you have the audio cue and then you have the visual cue. Those are the kind of feedback that are really useful in VR. Any other questions? Yeah.
In terms of design, you're working with all this new hardware, it's exciting, you see a lot of potential for it. How do you prevent feature creep in terms of
Preventing feature creep.
this? What actually gets you into pulling into the actual experience you want to make?
Yes, so feature creep is a deadly risk that we all face constantly. So the way that I generally try to address feature creep when I'm working with a new piece of hardware, so like I said with those two questions I started with at the beginning is what is really unique about this hardware and what can I do with this hardware that I couldn't do with another piece of hardware. I usually try to make that a single answer. So in the case of the ZSpace, the single answer was the 3D-ness of it is the most unique thing and the thing that we wanted to exemplify. So every decision we made, we asked ourselves, does this help reinforce the 3D-ness of the game and of the experience? And if not, we didn't do it. So we designed everything to take advantage of what the hardware had to offer, and we usually just picked one specific thing. In the case of the Wii balance board with the Kinect and the biometric feedback, we had so much hardware that like each one had its own unique thing that we were doing. So that one totally feature creep. That one was an explosive. Our milestones just like kept pushing and pushing. But we were working with the military, and they were like pretty happy to like keep letting us add more stuff. They're like, oh yeah, keep adding more things. So that was a really cool project for that reason. But yes, feature creep is dangerous. So focus on the thing you think is most important. All right, well, thank you all so much. Really excited to be here.